All right, let's go ahead and get started. We have one item on the agenda today, CSI changes for volume health, presented by Shing. Shing, do you want to present? I can stop sharing.
Yeah, sure.
Okay.
Okay, so I talked about this 2 months back in this meeting, but at that time, the CAP in Kubernetes was still really in progress. So now that CAP was merged, we want to discuss this again in this CSI community meeting. So the CAP, the purpose of CAP is to add volume health monitoring support, and then the CSI driver will be able to get volume health information from the storage systems, and then we could report those. So for this first phase, we'll be reporting events for those volume health information. So the proposed changes for CSI will be controller side changes and also node side changes. For the controller side, we want to add a new get volume controller RPC. This will have a controller capability. Actually, we'll need the two controller side capability. One is the get volume capability, and so if driver supports get volume capability, then it must implement this get volume RPC, provide some general information for the volume. In addition, there will also be a get volume health capability. So if driver supports the get volume health capability, then it must also provide additional information about the volume health. And then the second change is to modify the existing node get volume stats RPC. So this is already the node get volume stats is already there. So we're just adding another capability, get volume stats health. So if driver supports that capability, it must provide health information in node get volume stats.
What is the thinking about splitting this between the controller and the node? Is it likely that they're going to have different bits of information?
Yeah, so for some of for example, the local volume, I think it can only get that from node. For the driver that has the controller plugin, it can probably get most information there. But information such as like mount information, that you will have to get it from the node.
I mean, I'm trying to think through how to implement this. So like file system corruption is probably going to mean that you can't even mount, right? Like the mount would have failed. So like
this is after. So this is like this is after the volume has already been provisioned. You are checking. So this is assuming that the volume is already mounted. You're checking if it's still really mounted, because currently there's no check-in after you're done with that volume. You're provisioned, it's been used, then we are not really checking underneath what happens. So this will be on the node side. If it's already mounted, at least that's the information that you are currently getting, thinking it's already mounted. Then in this case, from the node side, you are check, okay, it's still mounted. If it's not, then right now we are just reporting, but in the future maybe we'll try to remount.
Okay, so you're thinking of the case when like the disk developed bad sectors while it was in use, and
right, or it's somehow right. Those are so those are different. There could be different arrows, right? So
The reason I'm confused is like if the disk has bad sectors and the file system somehow got corrupted while it's not in use, now presumably I can't publish it to any pods because I can't mount it because it's broken. And so at that point, how do I get the node information if it's
unmountable? It was already bad before even you are using it?
Something, well, it was bad and then I stopped using it. Now I'm trying to use it again and I want to get a status. I'm just, all the node plugins sort of presume that you can stage and mount the thing before you can start calling the rest of these APIs, and the type of errors you're looking for are the ones that would prevent you from staging and mounting, possibly. And so how does the node even know about this volume?
If it's not really mounted, then you couldn't find out the information, right? I don't know if is that possible to get that from controller side or not. You would need to know.
I'm just trying to think through
some of those I think those are the section that we still need to decide. Some of those maybe can happen you can maybe get the information from either the controller or the node, but others maybe you can only get it.
Is there a way to refer to a volume on a node that has not yet been staged or published?
I don't think you will have to know that it's already mounted for us to, for this node agent to find out, right? So how does this node agent know what volumes to watch? It has to rely on existing information, right? So this is actually, this CAP is trying to look at something that has already been done and look at, what happened afterwards. So if it's before, so that type of information, I'm not really sure how to prevent if it's already bad, that I'm not sure, because you're not even using it. How do you even assume that you're still going to use the same file system, right? So maybe after you mount it,
I guess I'm imagining the case of you have some local disks that you're treating as CSI volumes, and so that they already are attached to a node just because of the nature of the CSI plugin that's using local disks.
So local storage is different. Local storage, it should know actually. Michelle knows this better, right? So I not really have not really worked with local storage, but for local storage, that you will have to get it from the node side.
Right. Well, and what I'm getting at is if you have to get it from the node side, but you can't stage or publish the volume to any pod because it's corrupted, how can you even refer to it at the API layer so that you can ask the question? Right?
Yeah, so I think in those cases, like if it hasn't been published yet, then the user ends up getting notified there's a problem when you try to publish it and publishing fails. So I think there's like two different types of errors, right? There's errors at the time of trying to do these operations, and also errors where that can happen throughout the lifetime, after outside of these CSI operations.
Okay, so we're presuming that if it was not attached and we're trying to attach it and we detect the file system is corrupted, the existing failure message you get from that publish will propagate back and tell them that something is wrong. And we're only trying to solve the problem of something went wrong after it got published. And I want to know. Okay, that helps me.
I have a related question. So can the CO call this node get volume stats if the volume is not published or staged?
Okay, so that so the assumption, at least in the Carter CAP, is to assume that it's already published. Then we're trying to find out. If it's not, then everything will be from the controller side. So whatever the controller plugin know, then we can get. If the controller plugin does not know, then we can't really find out.
So the CO cannot call this RPC if the volume is not successfully published.
Or staged. That's how it's written today. Yeah. It has to be either staged or published to be able to do node get volume stats, and we're not changing that. At least I don't think we are.
Yeah, right. At least that's the current proposal, because this is trying to find out something you thought you were done with this volume. It's being used or something. Then, but something happens underneath, how you detect that. So the focus is that. So. Yeah. Okay. Good. Okay, so get volume request takes the volume ID and get volume response. This will have a volume in a response, and also in addition, there's this volume health. So we have, this will be a new message. The volume health will be a new message. This includes a error code and a detailed message. So I think this is something that needs some discussion. So right now we have a few common error codes proposed.
Any reason it's a string, not like enum?
It's I thought we don't want enum, because enum, we could do enum if that's better. I mean, I thought string so if we do enum, then it's kind of limited, right? I think this is not the common error code, but there could be other error codes that are not listed here, because there are a storage system. There could be many different errors.
So you want like a STT return, some kind of custom.
Yeah, it could be custom.
This is opaque to CO, you're saying.
So no, so this, well, so okay, so I think this is something that we need to discuss, because I think there seems to be two different opinions for this. So for this error code to be kind of spelled out to have common error code, then then in the future it is possible for us to do automatic reaction to it, right? To reconcile.
So you're saying it's semi-opaque?
So let me, so this is something we need to discuss, right? So basically, some of the error code, right? So for example, I was just thinking, for example, unmounted, this is something I think we could potentially just try to mount it again. Like volume not found, maybe for like stateful set, maybe stateful set could try to create it again, something. That's something that we need to discuss. So
well,
some
hold on.
of
if the volume wasn't found, you get a gRPC error when to the get volume.
No, this is right, but you do get that error, but this is, we're just trying to say, okay, this volume is still there, right? We're not really in Kubernetes, we still have those objects, right? So we're not deleting it. This is just to tell you something's wrong.
But what's the difference between a gRPC not found and a successful
I think the case Xing is thinking about is after it's published, someone went and behind the covers and deleted the entire volume while it was still published.
Okay, but I think most plugins would, according to the way the spec is written today, if you call it any operation on that volume, you just return not found.
No, that is
no. I think the thing is there's no operation, right? It's already been published, but someone went and deleted the volume. Now the application is probably getting IO errors or something, but like they don't. Besides, I guess they should get notified of IO errors. But I think that
if someone issues a get volume call as it's described here, why wouldn't the get volume call just return?
Get a what? I'm sorry. Get a what?
This is part of the get volume call, right?
This will be get volume. Yeah. So this.
So if I issue a get volume call, why would the gRPC would return success with a health code of volume not found versus
so this
gRPC not found?
Yeah. So that is maybe more appropriate for this particular one, right? But there are also other type of errors that we want to monitor. So this is something that we could, if it's get volume, then that one should just return and say not found. That's probably a pretty standard one that we could use. But there are also all kinds of other errors we need to decide how to.
So some of these I get. Out of capacity, disk failure, disk removed, this removes is a little funny, but volume unmounted is another one that like that.
Which one?
Volume unmounted is one that CSI, like the CSI state machine, should understand. Like if it's published, it better be mounted, and if it's unpublished, it better be unmounted.
No, but this is like something happens. This is something happens underneath, right? This is not like when you are trying to mount that happens. It's already mounted. You are not doing anything. Then this suddenly happens.
But the CSI plugin is responsible for whether it's mounted or not, and so
it is.
Yeah, but
yeah.
I think there's like the case where I think for a lot of some of these errors, there's like the case where someone actually went in behind the CSI driver and, you know, unmounted the stuff manually.
Yeah.
That kind of thing, right? So from that point of view, it wasn't a CO calling node publish or unpublish that triggered the operation. And those are like some of the kinds of errors that we want to detect.
Yeah, I'm just trying to think through like what can you actually do that with a running pod, and will the kernel let you unmount it, or will you have to kill the pod first? Because the pod will all have its own mount, its own bind mount. That unless you go inside the pod and unmount it from inside the pod, I don't think you could actually unmount it.
I think what would help me understand some of these error codes, or at least the need for having them in the spec, is a list of, or not even a list, but just like a suggestion of like whose job it is to remediate the problem and how they would do that. Because if it's something that, you know, a CO should do, then that's cool. Like, let's include this as a code. But if it's something that a person has to do, I'm kind of wondering about its value as an error code. Because like most of our error codes throughout the rest of the spec, you know, we talk about how the problems should be remedied, and these don't have any of that information there. So I'm at a loss for.
So I actually agree with that. Like for things that humans are supposed to respond to, the best thing to do is to log them or shove them into an event stream, rather than have them represented in some API. But like the benefit that I do see is this is at least a standardized way for all the different CSI plugins to have all their statuses sort of filter into a single log stream in a standardized way.
Yeah, I'm gonna strongly +1 that too. Having recovery behavior clearly dictated will help here, because the point of having well-defined error codes is to allow for programmatic recovery. And if we are not aiming for that, if this is just informative, then we could have an opaque string, and it doesn't matter what goes in that opaque string. But if we do want programmatic recovery, we need well-defined error codes. If we're going to have well-defined error codes, we should say who is going to consume it and what are they going to do with it? What is the expected behavior?
But there is a little bit of value in the opaque string, and just in terms of being able to collect all the errors from all your volumes and log them in the same place.
Sure, but we should be very clear about that and say, well, if we're going to have an opaque string, let's have an opaque string and let the storage system pass whatever they want, and be clear that the consumer here is just passing it along to the end user. They're not going to programmatically operate on it.
Yeah, I agree that the semi-opaque comment I made earlier was a joke, because that's a horrible way to do things.
I agree.
I wonder if we should have maybe narrow down a couple of them that we might be able to automate some way to fix things.
Well,
maybe a lot of those are maybe not, right? A lot of those are probably user will have to manually fix it, or user will have to, well, there is a way to write some script to automate this, but it's probably very specific to some application.
Yeah, the ones that you have listed here all seem like they need user interaction, aside from volume not found and volume unmounted, which only seem like they could occur if somebody did something maliciously.
I do see some value though, even if we don't operate or automatically recover from things, to I think there is value in standardizing at least common error scenarios. That way, if someone is if say someone is using multiple storage systems in their environment, you know, having like the same error messages or error codes propagated up could make their sort of monitoring more consistent. They can set alerts on specific error codes and that kind of thing.
I don't know if we can do that, right? If we are saying that we can't have a programmatic response, that it's complicated enough, there's enough subtlety and difference in the way that you respond that you require a human, can we then say that we're going to be able to define a set of standard error codes that are going to apply to enough of the different types of storage systems?
I mean, there's some things I think are fairly common, like file system corruption. I feel like that is something that probably all storage systems could encounter at some point.
And the alternative is if we leave it up to the storage vendor to define that, one storage vendor would say it in a different way from another, so that a user would have a difficult time of interpreting it, or
potentially, or managing it, because if say they want to set alerts on something, then they're going to have to set alerts specifically to every set of error codes that a particular storage vendor defines.
Is there a set of use cases that, or like production scenarios that people have run into with CSI that you could say, okay, well, in these cases, if I had these particular error codes, my system could have handled this better for me? Like, do we have those use cases, or we're just kind of, you know, guessing?
There are use cases in the beginning.
Okay, sorry.
We probably didn't. Yeah, well, we didn't really go through the beginning because we probably wouldn't have time to go through. But I don't think we talked about how to react, though. I think it's really, so there are use cases basically listed. There are use cases.
I think what the consumers of this will really want to be able to do is to figure out, like, is the error bad enough that I should just basically give up on that volume and go use a different volume, or should I wait for someone to try to fix it because it's a fixable problem?
Would it be maybe useful then to at least try to standardize on like the severity?
Yeah, that's where I was going. Is maybe we could standardize on at least the severity of how bad the problem is. Like, it's a recoverable error, it's not a recoverable error, and so that because a higher level, like some application that's running on the cluster that has multiple volumes and is doing its own replication, if it loses one of its volumes, it has to decide: do I start replication to another volume, or do I wait and hope the volume comes back? Because both options are fraught with peril.
Yeah, that makes sense, because yeah, that's exactly the type of decision the end user will want to make, and it doesn't need to be as granular as the type of error.
So file system corruption might have the automated recovery use case if the file system has like a repair option. So there might, you know, someone might want to automatically see that error and try like an XFS repair or something.
Yeah, but every file system will be different.
Yes, that's true. So it wouldn't be handled by the CO necessarily. It would have to be some other automated controller watching on the volume or something. And then, but what I'm saying is it doesn't have to be a user interfering. It could be something that the user wrote that can automatically handle this based on watching this object.
But then they can subscribe to their vendor's specific code for file system corruption for their CSI plugin, whatever that is. It doesn't have to be standardized, as long as the vendor documented what error code they used. Yep. Then it's up to the user to read the docs and look for that error code.
Sure,
Well,
but then it gets harder to write a common open source controller that anyone can use.
But I think that's what we're saying, is that storage systems are going to have enough kind of differences in the way that you recover from them that you're going to have to write something custom anyway. If you're going to write something custom at that point, standardization doesn't make sense because you're writing something custom for the storage system anyway.
Yeah, I think it's sort of a pipe dream that we could ever have a generalized recovery system that can look at these error codes and just fix all of them, or
maybe
any.
not all of them, but maybe your application only use a few storage systems. Then maybe
well, if we can find just one, then they'll standardize it.
I'm just saying that like, for example, this files and recording, that's one use case, right? So it's possible that your application, you're using, let's say, 3 storage systems, and maybe there's a way for you to standardize that based on this error code. That definitely will help a lot. You can automatically solve that problem.
So for example, like I'm thinking back to like the severity comment, right? Like what's the higher level, what's some kind of higher level term that we could use to describe something that is more easily actionable, right? Or at least if I can decide whether or not I need to take an action, right? So maybe distinguishing some kind of service level, right? Like the storage is online, or it's online but it's degraded, or it's online but it's the data is not available, right? So like the volume's there but the data is gone, but the data is inaccessible, right? Because at least if it's degraded, I can still get to my data, but then at some point I can't get to my data anymore, and like that's a higher priority issue, right? So like maybe we can break it down in a way similar to that. So there's like different categories of
how bad it is.
Yeah, like severity, right? But whether we call it severity, whatever you want to call it, right?
Yeah. So we actually have like 4 levels, like red, yellow, green, and unknown. So red is very severe. Basically, you're not accessible to any nodes. Yellow meaning you still have accessible to some nodes. Green is good. Unknown is unknown. So that's the most simple way. But that doesn't really tell you all of this type of error codes, but just very general.
Well, there's nothing wrong with having an opaque string that gives you the details about what exactly is going wrong, but we need.
Okay, so like you're saying that kind of a common thing will be like red, like this, maybe failure or warning or error warning, something like that, info, something those type of level, like 4 levels type of like. And then other than that, opaque string to indicate what is the error code, and then message those are opaque or something like that.
Yeah, that sounds right.
Like the real use case is like somebody has some stateful set that has multiple replicas, and then they want to be able to set something that says, if one of my volumes ever goes to severity magenta or whatever you decide, then I should create another volume and another replica because I don't expect that one to ever come back. But if it goes to severity orange, then I'm going to wait for a human to do something and not start replicating to another copy yet. And that would be my check. If it's really bad, I'm going to start a new replica. If it's not so bad, I'll wait for a human to do something.
Yeah, I like this idea of starting with some sort of severity and an opaque string that storage vendor can stick whatever they want into. I think that'll be sufficient for us to at least do what we want on the Kubernetes side for our alpha, which is just surface events to the user, which can be opaque, and that's perfectly fine. Moving forward, we can see how useful the severity field is, and if we need more finer grained error codes or not. And I think we should definitely follow the alpha beta GA that James had put out for the CSI spec for this. That way we could put this out as alpha, test it out, feel it out, see how useful it is, and then modify it as needed. If we find that the severity concept doesn't make sense, we can rip that out and try something new.
Okay, so all right, severity, that'll be like enum, 4 levels, red, yellow, green, unknown.
I would probably, instead of using colors, I would use like fatal, degraded, okay.
But whatever we choose, you better be able to write what it means to the CO in very precise language, like that. Otherwise, it's just another opaque thing.
Yeah, so fatal, basically, that's just unrecoverable. You have to do something. Degrading is more like a warning. Then maybe you can wait, or and then okay, it probably also probably should have unknown. Sometimes it's unknown, right? So something like that. 4, enum.
I don't know. You want to be able to distinguish between your data is definitely gone versus like it might come back someday. That's a useful distinction.
Yeah. Okay. And then okay, so then the error code and message, those are all okay. Those are all opaque. Basically, we don't really provide common ones. We'll see how that goes.
Yeah, I think what I'm imagining for the severity categories is that we don't get too descriptive on the type of error that could cause that severity. Instead, we leave the name to kind of be representative of the behavior that the CO will do. So I like what Michelle said about like fatal or degraded, and then I don't know how we would fit in data permanent or data, temporarily gone, something. I don't know what that would be, but if we focus on the CO kind of interpretation of it, what that means is that the storage system can then decide whatever error they end up with, how it should map and how the CO should kind of surface or handle it. And it'll make it more flexible in the future.
Okay.
Well, there's 2 statements that kind of matter about, when you're asking about how is my data doing. There's, can I get at it right now or not? And there is, am I likely to be able to get at it in the future or not? And those are 2 sort of independent questions, right? That you could have a volume that's offline, but your data's fine and you'll get it back tomorrow. Or you could have a volume it's fine now, but it's just throwing a bunch of smart errors and it's likely to crap out tomorrow.
Do we even want data to be a category? If we just have fatal, degraded, and green, or like healthy, if you are temporarily unable to access data, then you say degraded. If you are permanently unable to access data, you say fatal.
Well, I don't know, the word degraded means something else to me, which is, like I have a RAID group in one of my disks and the RAID group is gone. So RAID group is reconstructing. Like now I'm at risk of something worse happening. But your data, you can still read and write to your RAID group, and maybe you have slower performance.
I think what you're saying is like there is the health of the underlying disk and there is the health of the data that lives on top of that disk. It could be that the underlying disk is perfectly healthy, but the data has either been temporarily or permanently lost, and those are two different kind of states.
Yeah, I guess. I mean, like when I there's multiple layers of reliability in any sort of storage system, right? And it's like, which layer has gone bad here? At some point you have enough errors that you just recovery is hopeless. Right. But if there's hope of recovery, and you're in that window where you're trying to recover but you haven't done it yet, like then the upper layer might want to know about that, because might be doing a RAID rebuild, or you might be trying to get the data off the bad disk onto a good disk, or
But I mean, like if we look at it from a Kubernetes operator perspective, or a CO operator perspective, like what is it that they're going to want to know? It is
I think they want to know, can I get my data now or not?
Right.
If I can't get it now, like I just need to step back and wait.
Okay.
Or if I can keep running with maybe in caution mode. And then there's the question of, if I can get my data, is it likely to go bad tomorrow? So maybe I should move it somewhere to a safer place while I still can.
I guess what it is, hey, something is wrong right now, but it may come back to health. It will probably come back to healthy in some time. So just FYI, this is temporarily degraded. And then the second case is failure imminent, like, hey, something on this disk is about to fail. You better get your data off of it and replace it. And the third is the disk is gone.
Well, and the fourth is everything's fine, right? The
And
good
everything's
case.
fine, right?
That's an important case. Hopefully the common one.
Okay.
Yeah, that's how I think about it. Yeah, it's.
Well, but then if your failure imminent, that will be the fatal, right? Or is it not?
No, that means that your app can keep running, but like there's reason to worry about a failure soon. And so if you have the ability to create a new replica somewhere better, you might want to go ahead and do that now, right? And then that's a decision a human or a machine can make with some policy. But that's useful information to surface up from the storage system that, hey, I see errors. I can still give you your data, but I don't know for how long that will remain true because I'm seeing errors, right? Like this is what SMART does down to the hard disk, right? SMART is about looking at various sensors and trying to detect failures before they happen.
Can we think of other possibilities?
I mean, you could make statements about degraded performance, perhaps. Say, well, you know, I can give you your data, but it's going to be slow for a while because something is happening on my CPU that's slowing me down.
Temporarily unhealthy, I think, catches that.
Yeah. I wonder how much utility there is to an unknown, because there will be situations where you can't make the call, but what is the higher level system supposed to do with an unknown? It's kind of not very helpful.
Yeah, I have to wait. But if it's unknown, then it is unknown, right?
I mean, if we're going to make an email out of this, there's going to be an unknown anyway.
Yeah.
Just to allow for compatibility. So.
I imagine systems will treat unknown the same as healthy, right? They'll say, well, I mean, hope for the best. Unknown probably means it's okay.
Yeah, I think that for backwards compatibility will need to be the case. Okay, this is going to be one of those things that we're probably not going to get right on the first shot. So definitely let's go through alpha, beta, GA, and let's see if we could find ways to poke holes in it as we go along. Let's be very, very cynical and think through all the way to how it's going to be surfaced and used. But ultimately, I think it'll end up being pretty useful.
Yeah, okay, sure. Okay, so looks like we haven't really decided on this this middle cases. Okay, so we know fatal is healthy, and then in the middle, do we need two type of warning or
the 5 cases?
Okay.
I have healthy, volume is temporarily unhealthy, death imminent, dead, and unknown.
Okay.
I don't know if those are the final names we want to come up with, but that's the general categories I think we've discussed so far.
Okay. Okay, so we'll move to the thing we already talked about. This we'll have a get volume house capability, and then the node. We use node get volume stats. So most of those are existing. It's already in a spec. We only added a volume house here in the node get volume stats response. Cool.
And we really do believe that the node is going to have access to information the controller won't.
Right.
So,
yeah. In this case,
it adds value to have more information.
Right.
Because I'm not convinced of that, but I'm willing to believe it.
Yeah, but it's not every plugin has the controller plugin, right? So they have to use this the local for local storage. It's going to be on a node. You can't get it from the controller, right? So
like for things related to like mounts and IOs and file systems and stuff, you'll have to get that from the node. I'm not sure the controller is going to really be able to report things like that.
Yeah.
I think it depends on the architecture of the plugin. And at some point, I wonder what the value is going to be of having these redundant APIs. But I guess I'm not familiar enough with all the different implementations out there to understand the utility of this. So
yeah, I mean, it might be good to have like an example of how this would work in like a plugin that didn't have a controller plugin and how it would work in a controller that did have a controller plugin. But I mean, I get that we have enough different CSI plugin styles that having two ways of getting the same information tends to be needed.
Yeah. NFS might also only has node plugin. NFS local storage. Yeah, there are a few that they only have node plugins.
But NFS won't be able to tell you anything from the node.
Yeah, maybe, but I mean, but for locals, I think this is a big use case for local storage. That's how this work gets started.
Yeah, well, and for sophisticated arrays, the controller probably has access to all kinds of APIs to figure out what's going on the array. So
yeah,
the controller plugin having tons of information.
Yeah.
For in certain cases.
Yeah, but still, it won't have the information, like the mount information. Those information still does not have, right? It doesn't even know unless, or it can maybe go out of its way to find out all the nodes, go through all the nodes that are there and go do those type of check, but it's kind of excessive.
Well, yes, there's certainly some information that the controller plugin doesn't have. I'm just trying to figure out, is that information relevant to health? That's the part that I'm not convinced about. I can imagine it is.
Yeah, like the mount, like the mounting information, those are relevant. The right IO arrows Michelle was mentioning, yeah, those are relevant, right? You're not mounted, then controller, how can controller know that if it's not even mounted? You don't have a file system. Where do you get those information?
Well, IO errors have to come from somewhere. They have to come from the controller, presumably. How could they come from the node?
Well, it can from a node when you write to the file system.
You can get the file system stats, IO stats from the node.
Right. That's really the value of what the node has. Is it has the VFS layer in the kernel and it knows what's going on. But like an IO error would typically be because the underlying storage returned an IO error and it's propagated back up. But the controller will know about those because it started them, it created them, right?
So now this brings up an interesting question. Like, I think what the question at hand is we have two different ways to be able to represent volume health or to query volume health. One is through the controller and one is through the node. Presumably we're saying that they return the same set of information, which is severity and an opaque code. And so, and what we're saying is that we may not always be able to get information from both. So for example, on the node side, you only are able to get health information as long as a volume is successfully mounted. And so how does a consumer of this information then consume these two signals in a sane way? And how should it be presented? So if you have a node saying everything is healthy, and the controller saying, oh, it's degraded or is in a imminent death state or vice versa, how should that be surfaced to the end user without being super confusing? And
return the worst.
I think if they're using a common error code, might be a little confusing. But so in this case, you do have to look at what is the error code, what is the message. Those two, if you implement both, then they should be watching different information. Like our controller will be, our controller side will be communicating with the storage system, but the node doesn't always really communicate with the storage system. It's only looking at the node side information, not really communicating with the underlying storage, because it's only watching the mount information. So it will be, I assume like our driver will be provide different information from the node side and from the controller side. Very different, actually, very different view. It's not going to be redundant.
I understand it's different views, but like if we're saying something like healthy, volume temporarily unavailable, death imminent, death and unknown, and you have, for example, controller saying death imminent, but node saying volume healthy or something. How do we, where are we going to surface that?
Well, so right now, those are all in the events, right? So user will have to go look at events, and then those should have the error messages in there. They can look at the error message. So the only rely on the severity level. Well, that's still relevant, but they need to look at it whether it is from the node side or from the controller side. So I wonder, should we have different severity levels from, if it's from controller side or from the node side? Should we somehow name them differently so we know where that's coming from? If they're all the same, then maybe confusing. They read the message, the detailed message they can see, but otherwise. Like controller fatal, node fatal, something.
Yeah. I think at that point we are leaking in our internal implementation details to the user. And
I think you kind of need to view it as like two different event streams that have to be merged together, because, of course, if an error is only visible to the node or only visible to the controller, then the other one will say, yeah, it looks fine to me. And only one side will see that there's a problem at all. So you have to.
But right now we're talking about logging the events, right? So the events will be controller will log the events, and then node will log the events whenever it happens. It's not like only one place log the events.
But somebody who wants to consume this information and react to it is going to have to watch both streams and sort of have to look at the worst information coming from either stream. And although I guess that there could be pathological cases where the errors themselves are being misreported, and then what do you do? Like if one side says it's fatal, it's dead, and the other side says, nope, I'm fine, I have the data. And it's like, well, that's weird. That shouldn't be able to happen.
So an alternative, and this is not, I'm just brainstorming, going back to something Ben said, we could put the burden on the storage system and require them to have some back channel between controller and node, and let them make the decision about what to surface to the end user, and then simplify the CSI driver interface to drop the node part, only have the controller part, and then it is up to the storage system to figure out how to collect and get the node level information to the controller call and figure out how to do the resolution if there is a conflict between the information they have, because ultimately the storage system is the one that's going to have the most complete information about how to do that resolution. But it does increase the bar for writing the
Yeah, I think that's going to be very hard to implement, because the way that a lot of plugins are architected is that the controller piece is completely independent from the node piece, and they're two completely different processes.
I mean, could we tackle this work in stages? Like just do the controller piece first and see what that buys us, and then if there's a need for the node stuff, tackle that after?
I like
I'm
that
not
idea.
familiar.
I feel like it's actually maybe easier to detect node side stuff because you can leverage, at least for like block storage systems, because you can leverage the VFS stats.
But what are you getting out of there other than the stuff we're already getting for get volume stats, like files and bytes? And
you can get like IO data in terms of the performance and also errors that you get from
you
IO.
can get errors. Okay.
I think, yeah.
I mean, my one concern about doing this all on the controller side is what about the SPs that only have no plugins? Like now they're forced to either not implement this feature or implement a controller plugin just for this feature, which seems weird. But
I mean, I'm fine asking plugins to implement a controller if they want advanced features.
Yeah, I mean that's a good argument. This is an advanced feature. You need to have.
Could it be if you only do this on node side, could get redundant information because some information you really only need to bubble it up once from the controller. You don't have to show the same thing from all the nodes, right? So the things, if you're only doing on the nodes, it could be every node get the same information and you're showing the same information multiple times.
Right.
That's the problem, I think. But I think the controller side one is important.
I mean, speaking for someone who has an actual storage system with a controller plugin, like we do have access to tons of information from the controller on exactly what's going on with every volume, including health information that goes really, really deep. So if it was only on the controller side, we could do interesting things. But we're not dealing with like local disks in the nodes where the node plugin would actually have an advantage. So
yeah, I know. Yeah, that's the thing. I think actually Nick, when he first started this, is only for the local storage. So it's the only controller side. He's like, do I still want to work on this? Yeah, for us, it's actually controller side work at a lot of information already, so it's very, very helpful.
I'm still not convinced that the most storage plugins that implement the controller piece will be able to get all that data. I still think having the node side would be useful.
Philosophically,
Yeah.
right? It's
I mean,
matter of whether they're doing it already or not.
It would be, I think, for a plugin that either only implements node or it has a controller piece, but the controller piece doesn't really have anything. It's going to be a pretty big hurdle to sort of implement a whole control plane to bubble it up to a controller.
Oh, hold on a second. So if it's let's say if it's a local volume, I think that is only specific for one node, right? So what I was trying to say if then so if this happens on that particular volume, then you will only get that information once. You wouldn't get this on multiple node, will you? This is local for the local storage, Michelle.
Yeah, so say for like for local storage, then local storage would have to implement a whole control plane to funnel all of the nodes information to a single controller.
Yeah.
I'm not just talking about local storage. I feel like not all control planes may have all this information in general.
Yeah, so I think we do need both. It's just how to avoid confusion. So at least that's something we need to just think about how. So it's like the driver's responsibility.
I wonder if it's possible to change the design of the node plugin to, instead of piggybacking on like get volume stats, have like a get volume health for all of the volumes on the node, and then have it reported at the node granularity, because that would allow you to do things like address volumes that are not currently published. And there's a way to sort of correlate what the nodes are reporting with what the controller knows about, if there is one.
Sorry, so you're saying like instead of getting node get stats on after stage and publish, you allow it at any time?
Well, we're imagining the use case for this is someone's going to be polling, right? Every 30 seconds, however often, someone's just going to be calling this thing over and over because it's a pull model, not a push model. So
Sure.
why wouldn't you rather just have one thing that you pull and it says, give me all this volume health and all the volumes that you know about on this node, and then whether they're published or not, just let me know how they're doing, and then I'll figure out how to, get that information correlated with what what other things the CEO knows about.
Is it possible? I don't know if it's possible for the node agent to know this. If it's not, I don't know. I'm not familiar with the how that work, how the local storage work for. If it's not really published, do you even know what is there to watch? Because we need to know what are the volumes to watch.
I don't know, it seems weird to argue that the node has more access to information and then to also argue that the node doesn't know what it has, because that...
I'm not familiar with this part. Maybe Michelle can help me, the local storage part. I'm not sure.
Sorry, what? What's the question?
Would it be possible to, instead of having to query individual volumes on the node, just say, give me the health of all the volumes on the node, and whether they're attached or not, just...
I'm not sure if a plugin would have, I'm not sure all plugins can really reconstruct all that data. Like in the case of local storage, like I'm not sure the local storage plugin can actually really know which disks on a node are ones it owns.
But then how do they work? Like how...
I think it's basically up to the admin to sort of tell the plugin which disks to use, but I'm not sure, the plugin has a way to sort of discover like, hey, I know all of these disks are mine.
Oh, well, yeah, but I mean, if the admin is told it, then it could just report on what it's been told that it owns.
Yeah, but that means the plugin has to like keep a internal database or something of like every disk that it operated on.
Could be, well, I don't know. I'm just trying to think of, at scale, this is going to be a pretty hairy polling problem, pulling all your different volumes and filtering all those events back to a single place.
I feel like we're optimizing for making a very, very simple local storage implementation.
I don't think this problem is specific to local storage. Like I think we should take local storage out of this. Like I don't think
it is
we
one
should
of the more
be,
interesting use cases.
It is, but I don't think we should be special casing things because of local storage.
I agree.
Like even taking local storage out of the picture, I feel like having the node side health checks are very useful. I don't think all storage systems, like for one, not all storage systems implement a controller piece.
Okay, let's carry on this discussion in a follow-up meeting. We're over time by a couple minutes, and I think there are folks that have to run to another meeting. Should we schedule another follow-up? I guess the regularly scheduled one, I believe, is in 4 weeks.
Yeah.
Yeah, can we have something sooner?
I can schedule one in 2 weeks if that works for everyone.
Yeah, I think that would work for
That'd
me.
be great.
Kubernetes code freeze is in like 4 weeks.
Yep. So maybe we should do sooner than that. I could do next week, same time, if it works for everyone.
Oh, next week, same time, we have the data protection working group meeting at the same time.
Okay. We could do next week.
Okay, I'm gonna cut out for the next meeting.
Okay.
Okay.
Next week, 10 a.m. Same time or same day?
Oh, same date. You said just 1 hour before. Is that 1 hour before that?
Later?
1 hour later.
That
yeah.
conflicts with the Kubernetes stand-up.
CSI
yeah.
implementation. So what about Thursday before the storage?
Tuesday, 9 a.m. Pacific time.
Tuesday. Yeah, sure. Tuesday. So is that 11th?
11th, yeah.
11th, yeah. Tuesday at
9 a.m. Pacific.
9 a.m. Yeah, that should work.
Okay, does that work for everyone else as well?
Yeah, that works for me.
Okay.
Yeah, sounds good, Sud.
Okay, and G, good for you too?
Yeah.
All right, cool. I'll schedule another one for 9 a.m. Tuesday, the February 11th. All right, thanks everyone.
All right, thank you. Bye.
Thank you.
Thanks.
Bye.